Hi everyone, welcome to the video lecture series for HEAL 518. This video is about descriptive statistics. What are they? We're going to cover them today. We're going to start with defining descriptive statistics and distinguishing them from inferential statistics. We're then going to review common descriptive statistics that we're going to encounter in this course, and you will also encounter in health promotion and epidemiology work. And so I'll start out with some definitions. Some of these you'll already know from your work, but it's good to get a refresher. I'll talk about how you use them in descriptive statistics and also how to calculate them. And I'll show you some screenshots from Google Sheets about how do you actually use the formulas. There is a companion video that is called Formulas and Functions. I encourage you to watch that as part of this series so you learn how to calculate each and every one of the statistics that are in this video. All right, so let's start with types of statistics. And first and foremost, these are not types, they're really just categories of stats. So there are really just two categories. The first is descriptive statistics and the second is inferential. So descriptive statistics really just summarizes the character of the data you have. So you have a sample drawn from a population or a full population. So a full population is a census. So if you've got data for every single person in a group that you're studying, that's a census or a population. But if you have a sample, you've drawn a group from a full population to represent that population. That's no longer a census. And so if you have some information about that group, you can then describe that group. That's descriptive statistics. You have some information about trends. You might understand some relationships. So tell me about your data. This is the process of telling that story. In inferential statistics, we're interpreting the meaning of descriptive statistics. So we're looking at those trends and patterns. Do the trends we see in the sample generalize to the larger population from our sample? And are our hypotheses actually correct? So we might have a hypothesis that we have formulated at the beginning of our research and we want to validate it or reject the null hypothesis. We might also want to examine relationships between variables, like in a case control study for epidemiology. And we also might want to draw inferences or conclusions. We might be doing a randomized control trial and want to establish causality. So can we draw those inferences or conclusions based on the data we have? And so it's important for us to first start, though, with a good analysis of our data. What data do we have? So just to go back to kind of where this comes from, there is kind of a process to gathering data, and the relationship between descriptive and inferential statistics is pretty straightforward. Again, you start with a population, you draw a sample, and then from that sample you're going to draw some conclusions and inferences after you go through a very sophisticated process. You do a systematic data collection process that has some very strict standards, and then you have a data set. That data set then needs to be described and analyzed. You apply descriptive analysis to it, and then you conduct inferential analysis and significant testing. You can then come up with estimating parameters, which allow you to draw inferences or conclusions about the population. But here, again, descriptive data gives us kind of a sneak peek about what inferences we might be able to draw when we get to the inferential stage. But before we do that, we have to do some work. Because our data might not be ready for the inferential analysis phase, we might actually have to clean it up. And so what I mean by cleaning is the data might have some quality problems. First, it might not be in the format we need to do analysis. It might have some holes, meaning missing values. It might have some outrageous values, which we call outliers. So we need to do some work to understand what do we have? What are some of the things that we're seeing? And so that's what we're going to focus on here in this lecture. So a couple things, when you look at papers that report statistics, you are going to notice there are some differences in how descriptive and inferential statistics are reported. Most often, you'll see the first couple of tables, usually the first, sometimes the second table, have a lot of descriptive stats in them. So if you look at this paper, which shows here in Table 2, the study participant characteristics at the baseline for a group in a randomized control trial, shows the demographic variables like sex, ethnicity, age, and so on, presented for each of the two groups that was under study, the intervention and control group. It also shows a p-value, which we'll talk about later in this course, but it gives you a sense of the strength of whether or not this data was valid. So we have some very descriptive information of who was included in each group and whether or not those two groups were similar. So were they similar? What were their differences? We go down here, for example, in the health measures, we look at the systolic blood pressure and diastolic blood pressure. They don't look that different, but there may be a slightly different between the two. But when we look at the p-value, are they different? P-values usually have a cutoff point of 0.05, and in this case, they're not. Okay, so that's descriptive statistics. So we're not seeing any differences there. Does that bear out in the inferential analysis phase? So we're going to look here at table 3, which shows some inferential statistics in addition to actually reporting out some additional descriptive stats. It shows some estimated parameters here, and again, a p-value. And again, we're looking at systolic blood pressure and diastolic blood pressure, and it shows us those adjusted mean differences. That's the parameter they're reporting, and shows a reduction in systolic blood pressure by 2.47 points, and then a reduction in diastolic blood pressure by 0.93, and that's just the interventions in reduction over the control group. But you can note that the p-value says that's not a statistically significant result. So that shows you how you would report these two different types of statistics and how they would appear in a paper. If you scroll down a little bit more on this table, you'll note the PHQ-9 score, which is a measure of depressive symptoms, was actually statistically significant, and you saw a drop in PHQ-9 score by 1.67 points. But so the intervention here actually did work. So sometimes you find in these tables that you can actually really present strong data, but it's a very different presentation between these two tables. And it's important to generate statistics that are accurate. So what are the major descriptive statistics? There are three basic buckets or categories of descriptive stats. First is frequency. So this is your basic counts, your relative frequencies are what we call your percents. So the percent of a category appearing, like percent of people who have who are from a specific state, for example, and cross tabulation. So looking at two variables and stratifying by group. Measures of central tendency are a very important type of statistic. So this is your modes, your means, your medians. And then finally, your measures of variability or dispersion. So these are things like standard deviation and variance. So we're going to talk about these today, but I also wanted to just share two other types of terms you might hear. Univariate statistics and summary statistics. They kind of mean the same thing, although there's a little bit of difference between them. But essentially, I hear these interchangeably used when you're talking about descriptive statistics. So univariate just means there's one variable being analyzed. That might not always be true, but if you are looking at one variable, it's usually descriptive. And summary statistics just means that you are generating statistics that are typically descriptive to examine the character of a data set. Descriptive. So we're going to dig into these today. So let's start with frequency. So the first is absolute frequency. This is as basic as it gets. So this tells you how many times a specific category of variable appears in a data set. So this is like a tally or a count. So you literally count the number of people who come from Massachusetts out of a national data set. How do we use this? Well, this shows us representation of a specific category. For example, back to my Massachusetts example, how many people from Massachusetts appeared in a national data set. And so we can count that, absolutely, you can do that visually, but you can use Google Sheets to do that as well by using the count function and specifying a range of data. You can also look at the relative frequency, which is just looking at the percentage of that category or value relative to the total number of cases. So if you look at a full data set, you can actually look at the percent of occurrence or prevalence of that category in a sample or population. So you simply calculate a percent, which is just quite literally taking the total number of cases that have that category and dividing it. So you divide that and you multiply it by 100. So here's the calculation here. So this is a no-show rate for vaccines. So the rate of people going who were scheduled. So 2 out of 45 times 100. This would be multiplied by 100 to get the relative frequency. Crosstabs are another great way to look at frequency. These are also called frequency tables or cross tabulations or crosstabs. You can hear this is something that's very popular to look at, and we do this because we want to look at the breakdown by categories by variables that we think are interesting. So for example, here I'm looking at education level by vaccine status, or you might say vaccine status by education level. I might posit that there is a difference in whether or not someone pursues getting a vaccine, like for flu, based on their education level, and that might be true. So in this case, I've only stratified by whether they've had a high school education or not. And so here I'm examining the relationship between two variables across two groups. You can do this from actually multiple levels if you want to, but this is as basic as this view gets. And this can be really useful if you're trying to understand just basic relationships. So the next category of descriptive stats is central tendency measures. And we use these to help us understand what is typical numerically within the distribution of data. So all we're really trying to do here is to look at the distribution of your whole data set. You have a spread of data. So imagine you have 100 points of data, and you want to understand what's within that 100 points of data. Well, one way to do that is to look what's in the middle. How do you characterize what's in the middle? Well, there are three ways you can do that. You can calculate the mean, the median, or the mode. Now I'm going to tell you how to calculate each one of these and what, but we're going to talk about which ones you would use under different circumstances because it's not always obvious which one you might look at. So let's start with the mean. And this also means just the average. So what is it? It's the identifying the average position within a specified data set. And you just sum all the values in the data set, so most of us already know how to do this, but I just want to review it. And you divide by the total number of values in that data set. So in this data set, I've got 10 values, and I've taken the average and I've added all these values up and divided by 10 and gotten my value up here, which is 26.9. I wanted to share that you have to be kind of aware of the fact that you have to look at the influence of outliers or extreme values. For example, if I had the value 120 in this data set, first of all, that's not a real value. It might actually be an error because BMIs don't go up that high, and you probably would be dead if your BMI was 120. Does that make actually real sense? So you have to think about whether or not that means that your mean will then automatically go up, and is it real? So it can be highly influenced by outliers. So it's a useful calculation if you assume that all of your values are actually real. The median is not as affected by outliers as the mean is. It's a value within the specified data set that's the absolute middle. And you can calculate it by looking at the order of the data. So you line up all your data by magnitude, so you can just filter or sort them, and then select the middle value. And in the case of even numbers, you average the two middle numbers. So you don't average like the bottom and the top set of values, just the middle two values. So in this data set, I have an even number. So it took the middle two and then averaged those two to get the median of 162 in this set of weight. And so that's one way you can look at the sort of the middleness, I guess, if that's a word, of this data set. And another way you can look at central tendency is mode. This is not really great for small samples, which I'll get to in a second. But what mode does is identify the most frequent number within a specified data set. So imagine this kind of, this is a number of drinks that are consumed per week. So alcoholic drinks. So you've got a number of drinks per week. The number of drinks that qualify as heavy drinking if you are biologically male is, I believe, 15, and 8 if you are a female. And so if you look at this data set, it's kind of useful to know how many each of these individuals has consumed. And so I want to understand what the mode is here, and it looks like 2 might be my mode. Okay, great, but I'm looking at, there's some extreme values here. This is a really small sample. And while I have kind of the absolute frequency here, This is not really super helpful. It just tells me that the mode is 2, but it's really slanted on one side. Okay, well, that's kind of interesting. So let's talk about that slant. What is that? Well, it's called skewness. So what is skewness? Well, this is a measure of how much the probability distribution of a random variable deviates from the norm, the normal distribution. So I think we're all familiar with the normal distribution or bell curve. That's, you're seeing one right in the smack middle of your slide here, and that's a beautiful, very even, symmetrical distribution of data. There's no skew whatsoever. But you can see on either side of your screen some skewed data. So it's either skewed left, which is called negative skew, or positive skew, which is called right skew. And a tip here to know when you look at this, which way, if it's positive or negative, or right or left, is to which way the tail is pointing, which is really useful. So, for example, the one that's closest to my head here is the positive one. And the tail is over to my right, or your right, actually. So that is positive. So the right is positive, the negative is left. Nice tip. And so this is important because when you look at skewness, it just tells us that our data doesn't quite behave normally. And this will tell us that we need different tests in the inferential statistics phase. This is super critical. So when we do descriptive statistics, we're really trying to assess our next step in the analysis phase. And if we don't do the step right, we don't assess skewness using something called a histogram, which shows you where things fall out in different categories, which is why the mode might be really helpful. We're not going to know what to do, so we won't know which test to run. And a good example of this is that, for example, the mode here is over here on the left. It's the highest value when you have a positively skewed distribution of data, followed by the median, followed by the mean. But if I were on the other side of it in a negative or left skewed data distribution, my mean would actually be on the top. So more skew means there's more distance between the measures of tendency as well. So that can really change things up. We can actually measure skewness thanks to Pearson. Thank you, Pearson. Has done a lot to create measures for statistics, which we'll talk a lot about in this course. But just know that skewness is a really important concept, and as we get deeper into this course, you're going to understand that skewness is something we should be aware of and look at in terms of our data sets. All right. Now, when we look at central tendency and looking at these different measures, it's important to use the right central tendency measure when we look at our data. So if we're looking at our data spread on a distributive curve, so if we've put our data on a curve and we're looking at it, we want to also make sure that we're using the right measure of central tendency based on the variable level. Now, different variables have different levels. They can either be nominal, ordinal, or interval. And if they're interval, if they have a skew, then you should be using a median. If they don't, you can use the mean. So if they have a normal bell curve shape, you should be using a mean. But if they don't, median is a much better value to use. So just a tip there. Now let's look at the final category of descriptive statistics. So variability and dispersion. It's basically the same thing. So what do we use these measures for? So these measures help us understand the distance away from the mean for every variable you have in your data set. And by distance, I really mean dispersion or deviation. So those words all mean the same thing. So if you hear someone say deviation, it really just means how far away am I from the mean. Common measures here again are range, standard deviation, and variance. And let's start with the range. So the range is exactly what it sounds like. It's like, where is the one side of the data and on the other side? It's the spread of my entire data set. And so I want to look at the entire, like if I threw all my data on the floor and I ordered them from the lowest to the highest value, what would that look like? So again, it's looking at that curve, but looking at like the whole curve. The calculation itself is taking the highest value minus the lowest value and that variable. So if I take my highest value and my lowest value and I subtract them, that's how you find your range. Smaller that is, the smaller range, you mean the distance in between that mean and the whole, how that stuff spreads are going to be squished together. If it's much bigger, it's not as squished. So that tells you a little bit about that curve and how squished it's going to look. Squished is not a real way to look at descriptive statistics, but it's how I think about it. Standard deviation is a way in which we can also assess the quality of our data and to understand how it looks and how to think about it. Is the average distance of each value in your data set away from the sample mean. And how do we use this? It tells us whether the mean looks like the rest of our data, or is there a lot of variation? So for example, if you are rating the current sitting president and you're asked to rate that president on a scale from 1 to 5, and the standard deviation is 1.2 for one presidency and it's 1.7 for another, then, in a scale from, again, 1 to 5, the 1.2 has a little bit less variation than the 1.7, and so you would expect the 1.2 to be kind of a tighter curve and the 1.7 to be eased out a little bit. And so there's a bit more variation for the second presidency. And so you just want to be careful of looking at data to sort of make assumptions about what the mean actually represents. And so again, it goes back to interpretation. If your standard deviation is incredibly large, that means there's a lot of variation, which sort of tells you to be more cautious in your interpretation of what it means. And this is really important when you look at polls or in surveys, and that's your source of quantitative data. The calculation is really taking the mean of individual levels, and then the formula is available to you. But in this course, in Google Sheets, you can use the standard deviation function. And for variance, it's the standard deviation squared. So this allows you to get a little bit softer look at standard deviation. So you're squaring it out, and that allows you to average things out instead of getting a 0. So we'll talk a little bit more about variance, not in this video, but I just wanted to throw this out there as something to look at the overall variance of your data. Okay, so now your next task is to actually practice this. This video is also supported by the formulas and functions video in Google Sheets. So that is your next stop. Thanks for watching.